So, welcome back to this course, Professional Scientific Communication. So, in the previous lectures we looked into how do you develop hypothesis. Now, we are going to look into how do you you continue the topic on hypothesis and see few more examples as to why hypotheses are important. Frog is an important model for biology, especially those who are studying on the developmental aspects. Frog is extremely useful model because they lay egg outside, fertilization takes place outside, the embryos grow outside, therefore you can understand most of the developmental processes, and in fact much of our understanding as to how the embryos develop have come from frogs. So there is a famous saying by one scientist, John Rostand. We commented that theories come and theories go, the frog remains, meaning a number of theories have come in based on the experiments that are carried out on frogs, and they have been disproved, meaning theories have been broken, therefore new theories have been developed, tested, you do get knowledge, but again the theory was again proven wrong and so on. This is an anecdote just to tell how in science you always develop something, test it, and the theory is no longer viable, your hypothesis is no longer attractive, but that hypothesis did contribute to the advancement of science. You understood something and again you develop certain hypothesis and you go on doing more experiments. So what you are going to do is that how do you evaluate an hypothesis, because your hypothesis has to be very, very strong. So let us take some examples. This may not sound scientific, but I thought these are examples by which I can explain as to why it is important to have very good observations data to generate hypothesis. Okay. So hypotheses have predictive value. So you say this is what happens and it has a predictive value and you can test it. That is what hypothesis. So same thing, that is very similar things are being told in astrology as well. For example, your horoscope 2018 is soon coming, or when you are seeing this video already it is 2018, January, February, March, whatever, and you may be wondering how this year is going to be for me, right? So then, meaning you, and then you may look at your horoscope based on either your date of birth or the other aspects that are practiced, and then it will tell you good, bad, ugly, whatever it is, depending on what is your luck and so on, right? So this is again a prediction. Can this prediction be tested? Maybe yes, because it says in the beginning of the year that okay, if you are, for example, a Leo, you are going to have these things. You are going to find it difficult. Your monetary, your financial problem you will have. There will be somebody in your family will have health issues and so on. End of the year in December, you can go back and ask whether all this happened to you or not. Then many of the predictions, if they come true, would you believe that that is not a hypothesis? So this is how you sort of validate, right? So let's look into some of this. What does our horoscope say about your health, right? Let's look into. So these are, again, there are various ways by which people predict this, and then one is using the zodiac, your what is called zodiac sign, Rashi or whatever it is, depending on the month in a year that you are born. So there are certain examples shown. For example, that if you are a Cancer, then you may have problem in indigestion, intestinal maladies, and if you are Libra, you have excretory problem, and so on. So there are some predictions that are shown, right? So now, is it true? So that's the question. So how valid these predictions are? So maybe you can do that. Can this be tested? It can be tested. You can do that, right? So this is something that often I give as an example in the classroom at IIT when we do this course, and I ask basically the students to think about their parents, father, mother, which year they are born, what kind of ailments they develop, and try to make a chart, which is something that you may also wish to do. Talk to all your friends and then 20, 30 numbers, whatever, ask about their parents, in which month they were born, and whether they have some of these conditions, which are very common: asthma, diabetes, blood pressure, eye, ear problem, and so on. So you can put plus minus and sort of correlate and then test. If it is completely random, for example, then regardless which month you are born, you should end up having these ailments. But it looks like often it is not that random. For example, this is an indication that I got it in the recent class this year when I asked this kind of questions. Out of 15 students, this is what they have sort of listed, right? It's interesting because in some month, for example March, Feb, and October, November, December, you find those that are born in this these period of the year, they have developed, or at least those who have developed these conditions happen to be born during majority of them in Feb, March, April, or October, November, December. Does it really make? One possibility is that since the sample size is too small, possibly the majority of them are born in this month. That's a possibility. But this is how you develop an hypothesis and then test it. But if it is a large sample that you have collected and you can test this hypothesis, I am just showing you one of the papers. The paper is Birth Month Affect Lifetime Disease Risk, a phenome-wide method, meaning they have looked at the phenotype, they looked at large number of patients, and they are able to show some interesting correlation with regard to a given year or whatever, a month, birth month, does it give you a more risk of developing certain disease later in your life. What is interesting is this particular paper has come from a group in New York, and they have looked at all those residents of the New York City in the US. They looked at a large number of individuals. You can see that runs in thousands and lakhs, and then they looked at for almost 100 years period, right, 1900 to 2000. So that's a pretty long period. It's possible because most of the developed countries have very good hospital backup. This is social, the government takes care of their health, therefore they have very good records with regard to each individual as to what kind of ailment they had. So they basically looked at the hospital records and they come up with certain conclusion. So what they have done is they have looked at the records of these many individuals, right, and then they asked as to whether is there any correlation with regard to, for example, the birth month and the prevalence of a given diseases. So they have looked at 55 diseases. You can go and read this paper, it is available freely, and then they try to correlate, and some of the interesting correlations I'll discuss, but the conclusion is the lifetime disease risk is affected by birth month. If you are born on certain month, for example, you may be at higher risk of developing certain disease, not here in India, but if you happen to be in New York, I'll come to that a little later. Seasonally dependent early development mechanism may play a role in increasing lifetime risk. What they say is that for example New York, or if you look into most of the cities in India also, you have seasonal variations. January could be cold, and May, April may be very hot, and then it becomes humid, and then you have certain months that have the flowers blooming, you have pollen coming, or a lot of dust and things like that. So it depends on when you are young, you are exposed to different kind of environment. When you are just born, that possibly made some difference in your physiology, which now is called as epigenetics, which could possibly make you having a higher risk for developing a disease, or kind of a protection, we don't know. So this is this kind of study can really help us to come up with certain very good hypothesis. What I am showing is a few data. This is the bar diagram showing birth month affects basically individuals that are born in a given month, whether they have higher risk of having a disease. So wherever it is with a star asterisk, these are associated with birth month, okay, in the sense that allergy, asthma, rhinitis, these are the conditions that show a strong correlation for individuals that are born in a given month, right, and so on. So, we will go to some other more detail. This is what it is. For example, reproductive diseases. So, one that are shown in the orange color, the bars that go up. If you are born in December, November or October, you have a higher risk of developing reproductive disease. On the other hand, if you are born in July, then it sort of protects. The probability that you may develop reproductive disease in New York, if you are born and brought up over there, goes down significantly if you are born in the month of July. Likewise, there are some predictions for based on the data that these are correlations for respiratory disease, for cardiovascular disease, neurological disease, and so on. So, that gives you a good indication as to the birth month can modulate your physiology such that either you have an increased risk of developing a disease or it can confer protection to you in developing the disease, right. So, that is it sort of helps you to develop an hypothesis because this data is strong. It is not from 15 individual, it is from runs in 17 lakhs, and then 100 years of records, and it is a very significant data. All these individuals are from New York, one particular major metropolitan in the US, and you can correlate everything with that. So, now you can now ask, after all, the birth month is what linked to the different zodiac signs. Now, can we go and say now, well, whoever said about the zodiac sign and having higher risk of developing certain disease could be true, the prediction is correct, and indeed it's an hypothesis. What you need to understand is that the zodiac sign is applicable to anybody who is in the world, regardless which country you are, as long as you are born in the month of November, or you are born in August, or born in November, whatever it is, then it is assigned. But the climatic change, the seasonal changes that happen in one city may be very different from the seasonal changes that happen in a different city. Therefore, the environmental factor that modulate your development when you are young to either develop risk or to have some protective function in the lifetime diseases is depending on the environment in which you grew. So, there are some limitations, you have to understand that. The limitations of the study are, study population is from New York, thus applicable to only the New York climate, right. No controls, because you never said those who were not enrolled or born elsewhere and migrated. For example, New York has got huge number of Indians who migrated after becoming a graduate in India. They went and settled there to work. So, when they move in there, they are already 25 to 30 years. Now, they were born and brought up in India. Now, after moving in there, whether it changes, whether they also behave very similar way as they are the good controls. And then what is not looked at is socioeconomic indicators. For example, sanitation, your food habits, your lifestyle, they also could be modulators. So, if you are exposed to dust, for example, that means that your house is not well protected. You are exposed to cold, for example, that means your house is not insulated, you don't have heaters. If your house is exposed to extreme weather condition, for example, heat in summer, again your house is not air conditioned. For example, someone who is wealthy, could afford all the luxury, would have protected the house such a way that inside working temperature remains constant, the air is good, and so on. It may not affect as much as somebody who lives in house that is not protected. So, there are several different concepts that you need to look into, and then you arrive at certain conclusion. But that is how you develop hypothesis, and then to test the hypothesis. Now, based on the study of the New York population, this particular paper, you can develop hypothesis. Now, you can test using variety of models and control groups and so on, and validate indeed whether your birth month can affect the risk or lifetime disease risk or not. There are emerging reports which suggest that indeed that is the case again, but you need to consider what kind of climate that you are exposed to when you are growing up. Now, I am moving into a different problem in developing a hypothesis. These are again random data that again I use it in the classroom to explain as to how effectively you can develop hypothesis. And you can look at the table here. It basically looks at two groups of individuals. One is called as cases, osteoporosis, a condition in which the bone becomes brittle, and then there are healthy controls who are not having such kind of condition. So these are the two groups, and we are looking into a large number of parameters. Some of them are biochemical parameters, some are their habits and others. You can see that age is even, 60 to 64 is body weight, cholesterol level, blood glucose level, blood pressure, number of children that they have, monthly income, working for living, whether the individual who is having this condition is working or smoker, alcoholics, whether they do exercise, whether they have any family history, because there is a family history, then there is a genetic component. Basically this is what you look into, and then you need to analyze the data and develop an hypothesis. So by looking through the data, what basically you look at, where are the differences between these two groups. Based on this, whether you can develop certain hypothesis, right? So let's look in that way. First one, there is a huge difference between the osteoporosis cases and healthy controls in terms of the monthly income. You can see here the healthy controls earn less on an average as compared to the osteoporosis case. In other words, based only on the data, then your hypothesis would be higher the family income, higher the probability of getting osteoporosis. Is that true? That we need to analyze the data. Second, whether the individual who has developed this osteoporosis, whether they work for a living or they are just homemakers. And again you find those who work for a living, having a job, are at lower risk of developing osteoporosis. That means you get out of home and then do work. Is it an hypothesis? Is a correct hypothesis? The third one, again you look at the smokers and alcoholics, the percentage is very high in healthy control as compared to osteoporosis. That means smokers, drinkers are at lower risk. In other words, you smoke and drink, probably your risk of developing osteoporosis goes down. Now the data suggests like that, but what you need to look at is you have to critically evaluate the data, because these are data, they themselves don't say anything, these are raw data, but you have to analyze. What you need to look at is the sample size and for example the male-female ratio. If you don't really look into the demography, then you may not be able to get the real picture. So one of the indicators here is that the sample size, first osteoporosis is smaller, only 80 cases that you have looked at, and the control is 178, it's pretty large. So basically to avoid any sample bias, you should have had larger sample size. Second, if you look into the male-female ratio in the healthy control, it is almost like 1:1, right, 50% representation of female. But if you look in here, again it is male-female ratio is also very, you can clearly see that the female is overrepresented in the cases as compared to the healthy controls. So what does it mean? In a typical middle class family, what do you expect? Often the mother is at home taking care of the home. She is not going out for a job. So in that sense, she is not working for living, but she's working for everyone else living, right? So she's not earning income. And then often you will find that they don't smoke, they don't drink, but you may go to the healthy controls, you have a higher proportion of the males, probably they go out for earning, they also drink, they are smoke. So that is where the bias come in, right? If you look in, for example, again family income, here both of them are not working, therefore the income is low. In the healthy control, probably both of them working, the income is high. So here we know that if you're a female human, then you are at higher risk of developing osteoporosis because of the physiology, and indeed that's what being reflected because there is a bias in the sampling. So this is what is important when you develop any hypothesis. It is not that you buy any data or buy anybody logics. You have to evaluate critically and see whether the data is reliable, whether it is done with all the important controls, whether I can base my hypothesis based on the data. So data do not make a thesis. Remember that when you do any research, it's not that you have gotten some data that would make a thesis. Without an excellent hypothesis, which requires very good survey of the literature and very good thought process, defined outcome measures. So you have an hypothesis and you have measured as to what you want to do, and then this is what you are expecting that outcome, and a good methodology, because you have to ask good questions and you have to test it using certain appropriate methodology, and you need to have very good data collected. You have just now seen I have shown a table which is misleading if you don't look in carefully. If you don't have this, can lead to if you don't have this, it cannot lead to a meaningful insights. You may not really add much unless you have a good hypothesis, defined outcome measures, and good methodology and good data collection. Is not going to make a good outcome. Above all, a good thesis depends on an excellent hypothesis. Extremely important. It is more than coincident that the thesis is derived from underlying hypothesis. So therefore, it's important that you understand hypothesis. We have spent a lot of time on hypothesis for the very simple reason that you cannot start a research project without a well-defined hypothesis which can be tested, which has higher predictive value, which can be proven correct. Therefore, you have contributed immensely to a given field.